right, so we're going to do 11.3 matrices part 1. This is day 2 in the chapter. So today we're going to talk about matrices, or a matrix is the singular version of it. It's an array that's rectangular in shape, and it's used to organize your work or your numbers. Entries or elements are what we call each number in the matrix. So I'm just going to write the word elements here in case you hear that as well. And then when we talk about the size or dimensions of the matrix, we talk about the number of rows by the number of columns. So in this example matrix, there's row number 1, there's row number 2, so there would be 2 rows, and there would be column number 1, column number 2, and column number 3. So we call this a 2 by 3 matrix. Now we don't just say 2 times 3 is 6. 6 is the number of elements or entries in the matrix, but the size or the dimensions of it is 2 by 3. All right, so why would we want to use matrices? So yesterday we talked about solving systems of equations, either using substitution or elimination, which is great if you have only 2 equations. But if you have something like this system that has 3 equations and 3 variables, we're going to use a matrix that's called an augmented matrix to represent this system. So what makes it augmented is that it's going to have sort of a dotted line there. It's a 3 by 4 matrix. It has 3 rows, 4 columns, but the first 3 columns represent the coefficients from the original system of equations. So if you look at the coefficients of this matrix, we've got 1, 2, and 1, and this is noted in the first row. All right, and then in the second row, we have -1, 3, -2. That's noted in the second row. And then in the third equation, we have 1, -4, and 5, and that's noted in the third row. All right, so these numbers come from the coefficients. And then the last column in the augmented matrix comes from the numbers that are on the other side of the equal sign, which are constants. And you'll see that these are 5, 4, and 3. All right, so first all we're going to do is we're going to set up some augmented matrices. Now, if we were to do this all by hand, we would use these steps. But instead of making you do this all by hand, we're going to have our calculator do these elementary row operations for us. So you really are not going to need to know this, since we're going to use our calculator instead. All right, so let's take a look at the first example. So we have 3 equations, 3 variables. We're going to set up an augmented matrix. And since there's 1, 2, 3 equations, we're going to make sure we have 1, 2, 3 rows in this matrix. We're going to set up based on the coefficients. Now, these are already in order for us, so all the A's are in the first column, the B's are in the second column, the C's are in the third column. If they were not in order, we would have to reorganize the equations a little bit. But we're just going to put the coefficients, so 3, -1, -4. And then the second equation has 1, 2, and -3. And the third equation has 2, -1, and 2. And then remember, we're going to put like a little dotted line to separate the last column. And the last column is going to be related to the constants that are on the other side of the equation. So again, if these constants were not already on the other side of the equation, we would have to move them over to the right side. But we're going to write those as 3, 9, and -8. All right, and the size or the dimensions of this matrix is 3 by 4. All right, in the second example, we have only 2 equations. So since we have 2 equations, we're going to set up 2 rows. And now there are 3 variables. There's 12x, there's no y in this first equation, and there's -11z. So when we put this in our matrix, we're going to do 12, 0, and -11. And then for the second equation, we have 6, 6, and -4. So make sure that when you set up your variables part of the augmented matrix that all variables are represented, even the ones that you don't actually see in the equation. All right, and then the last column of our augmented matrix comes from the constants that are on the other side of the equations, which are 13 and 26. And the size of this matrix is 2 by 4, because there's 2 rows and 4 columns. All right, so now we're actually going to solve. This was just practice with setting up the augmented matrices. So at this point, you're going to need a calculator. And we're going to first set up the augmented matrix, and then we're going to use our calculator to actually solve the system of equations. All right, so let's set this up first. So count how many equations there are. We're going to have this many rows in our matrix. And again, notice if you're missing any variables. So I have a 1 for x, I have 0 y, and I have 1 for z. And then in my second equation, I have -3, I have +2, but I have no z's. So I put a 0 there for the z's. And then my third equation has 1, -1, -1. All right, so always just double check, make sure you don't have any mistakes for your elements in your matrix. All right, and then we're going to look at the numbers that are on the other side of the equal sign. So it's -2, 17, and -9. All right, and the size of this matrix is 3 rows by 4 columns. So we're going to need that when we use our calculator. All right, so at this point, we're going to use our calculators. So go ahead and take those out if you don't already have that out. And we're going to go to matrix. So matrix is above the x to the -1 key, so hit second matrix. You'll see the names of all of the possible matrices. We usually just put them into matrix A, but you're welcome to put it into a different one. So I'm going to move over to the right and edit. That's what I'm going to do first. So hit number 1 or just hit enter, and we have to input the dimensions. So 3, enter, and 4, enter. So you have a 3 by 4 matrix. So I have 1, 0, 1, and -2 for my first row. Hit enter, and you're just going to go across all the rows. Make sure that when you're typing in a negative value, you type the negative sign, not the minus sign. So -3, 2, 0, 17, and I'm just hitting enter after each one. And then my last row is 1, -1, -1 again, and -9. All right, after you've typed in the last number, you should double check to make sure you didn't make any typos. So positives are positive, negatives are negative. You don't have any of the numbers in the wrong locations. All right, so now we're going to actually run the command. It's called RREF, and it stands for Reduced Row Echelon Form. All right, so we're going to go to second and matrix, and you're going to move over once to math, and you're going to find on this list something called RREF. All right, so it's choice B. So in your calculator, you want to tell it to do reduced row echelon form of matrix A, or whatever name of the matrix that you decide to type into. So I'm going to hit second matrix again, or second x to the -1, gets me to the matrix menu, and then I choose number 1, which is A. So once you have that, all you have to do is hit enter, and then you get a new 3 by 4 matrix. It says 1, 0, 0, and then -5. I'm going to put my dotted line over here to do the augmented matrix part. And then the next row is 0, 1, 0, 1, and then 0, 0, 1, 3. So what this tells me is that this column, the first column, represents x. So for x, I get a value of -5. So this tells me that x equals -5. The second column represents y. So for y, I get +1. And the third column represents the variable z. And so for z, I get 3. Now, my final answer should actually be written as an ordered triple. So it would be -5, 1, 3. All right, so we're going to do 2 more examples of this. And these should get easier each time we do it. So as a reminder, we're going to be looking for what are our constants, and then we look for all of our coefficients, the numbers in front of the variables. If we don't see a number in front of the variable, remember we count that as a 1. So this will be 1, 1, 1, 2, negative 3, 1, 4, 2, negative 3. And then I'm going to put negative 4, negative 1, and positive 33 in for my constants. As a reminder, the size of this is 3 by 4. And we want to label the size of this because we have to type this in our calculator and you have to indicate what the dimensions are. All right, so hopefully remember what to do, but we're going to go second, x to the negative 1. That takes us to the matrix menu. We're going to move over to edit. I'm just going to type over the original matrix that I used for the last problem. So it's a 3 by 4 matrix. And I'm going to type in my new numbers. So 1, 1, 1. And then remember for negative 4, use the negative, not the minus key. And then 2, and then negative 3, and then 1, and then negative 1. And then for the third row, I've got 4, 2, negative 3, and 33. All right, when you're finished, double check that you didn't make a typo, you didn't leave out any negative signs, or put any numbers in the incorrect location. So once I have this, you're always going to quit, and you're going to do RREF of whatever matrix you just typed in. So I'm going to quit, go to the main screen. I'm going to do second matrix, move over to math. I'm going to move down to B. And then I'm going to hit second matrix and select A. All right, so I'm going to do RREF of A. And so this gives me an augmented matrix. So this augmented matrix tells me what the values of X, Y, and Z are. So this tells me that X is 3, Y equals 0, and Z equals negative 7. And my final answer is going to be as an ordered triple, so 3, 0, negative 7. All right, so our final problem, we're going to type in our coefficients in for the first part of our augmented matrix. We're going to write them down first. You should always show your work because I assume you want to get full credit on the quizzes. So even though you do all the steps in your calculator, you still have to show what is the matrix that you used for the problem. All right, so this is a 3 by 4 matrix. And I don't have any missing variables. I don't need to move anything over. All the x's, y's, and z's are in order, and the constants are on the other side. All right, so I'm going to go back to my matrix A. So second, x to the negative 1 to get to the matrix menu. You're going to go to edit. I'm going to hit enter. It's still a 3 by 4. And then I'm going to type my new values in here. So we've got 4, negative 3, positive 3, 2. And then I have 5, and 1, and 4. Oops, actually negative 4. And 1. And then the third row to represent the third equation is 9, negative 2, negative 1, and 3. All right, so when you're finished, make sure that you double check all the numbers are correct in the correct location, the negative signs are in the right places. Okay, so now I'm going to quit. And remember, you're going to do RREF of matrix A. So if I want to use the exact same command as last time, instead of finding RREF and then the name of matrix A, I can just hit second and enter, and it pulls up my previous entry. So I can just do that, and it'll run it, and it runs the new matrix that I just typed in, not the old matrix, because I've revised my elements in that matrix. All right, I'm going to hit enter. So this one's weird, right? It gives me like all these decimals, and if I want, I think I can do math and change it to fractions. All right, so what this tells me is that I have like a special case. So my matrix is supposed to have only a 1 in the x column, and then zeros in the other columns for y and z. However, I don't have that. I have zeros all in my third equation, the third row of my matrix. I'm just going to write these down, and then we'll go over what does this actually tell me. All right, so in my augmented matrix, I don't have the same setup as I did for the previous two problems when I got my answers. If you look at this last row, this represents 0x, 0y, 0z, and that equals 0. So it essentially is one of like their special cases where you either get infinitely many or no solution. And we have to evaluate whether this statement is true or false. So I would just look at that last row. And this tells me that 0 equals 0, which is actually a true statement. 0 does always equal 0. So that tells me that this is actually infinitely many solutions. So instead of having 3 equations that intersect in one exact location, I have multiple answers. And so in case you ever get a situation like this, just find the equation that has a bunch of zeros in it. If that last row was 0, 0, 0, and then like the number 5 or something like that, that would tell me that that would be 0x, 0y, 0z equals 5, which tells me that 0 equals 5. That would be false. And that would tell me that there would be no solution. All right, so that's if that had been the case. But for this problem, it actually was infinitely many solutions since 0 did equal 0, which is always true. All right, that's it for today's notes. If you have any questions, ask your teacher in class.